everyone. Thank you for joining us today for our ALS Webinar Wednesday series. My name is Malia Forbes. I am a marketing coordinator for ALS North America, and I'll be facilitating the webinar today. Before we begin the presentation, I have a few helpful notes. If you are having technical issues with our webinar platform, you can type a message in the bottom right-hand corner of your screen, and I will be able to assist you. You can also select the hand icon to notify me of your status, and I'll be able to assist you. All questions regarding the webinar material will be answered at the end of the presentation. Our presenter today is Howard Borse. Howard is currently Senior Chemist for the ALS Laboratory in Kelso, Washington. He holds a Bachelor of Science in Chemistry and has over 30 years of laboratory analytical experience. Howard served as Vice President of Columbia Analytical Services, which was acquired by ALS in 2011. Howard, thank you for taking the time to deliver this presentation. I will now turn it over to you.
Thanks, Malia. Hey, thanks everybody for joining. So today we're going to talk about analysis of contaminated sediments and related matrices for marine and freshwater environments. Contaminated sediments are of interest because they present a risk to the environment and human health and are a contributing factor to fish consumption advisories. So sediments become contaminated by many ways, industrial spills and releases. So you have urban and agricultural runoff, publicly owned treatment works that may be functioning not so well, and materials that just go through a POTW don't necessarily get taken out. There's contaminated groundwater, and even air deposition of contaminants are a few ways that, in the end, sediments can become contaminated. So ALS, we provide a full range of analytical services to support trace analysis for inorganic, such as metals, and organic constituents in sediments, freshwater sediments, seawaters, brackish waters, and biological tissues. And so today we'll give a brief overview on some of those services. Agenda. Here, we'll just go over a little bit of some regulatory and technical frameworks. We'll talk about the all-important procedures of sample prep, and a little bit about pore water, geophysical and conventional tests, and then on to some trace metals and trace organics. These are all going to be a very brief overview, so we're not going to take a tremendous amount of time in going in depth on a lot of this. So over 25 years, ALS has supported development of specialized procedures to meet special objectives for various projects associated with marine and even freshwater applications. So we support a wide range of sediment programs. So under dredging material management programs, those may include deepening of navigation channels, maintaining dredging of docks and harbor areas, evaluation of the dredge material for beneficial reuse of maybe upland or even open water disposal. And we do water quality monitoring, support water quality monitoring programs as well. Under contaminated sediment remediation programs, we routinely characterize the sediments that have impacted sites along river and harbor and estuary systems. We'll monitoring during contaminated sediment remediation activities such as dredging, and we'll support monitoring during post-remedial work. And at the end of all of that, we'll even do analysis to see how effective natural recoveries have occurred under MNR programs. Water quality assessments and compliance programs. So we'll support bioaccumulation studies, tissue analysis, ecological and human risk assessment programs, fate and transport modeling, TMDLs, and also fish consumption advisories, again through sediment or tissue analysis. So sediment management decisions are usually made with a lot of complex regulatory and technical framework and requirements, and it's not uncommon to see competing and conflicting requirements set by separate federal agencies with additional involvement from state regulatory programs. So we've supported various projects related to or fall under regulatory activities. Some of the following organizations: the Corps of Engineers, one of our bigger clients, of course, EPA, Fish, Wildlife, NIPS, NOAA, and DOD. All keep us very busy in this arena. So we're also well versed in the performance of sediment program testing in accordance with major federal and interagency regulatory requirements, guidances, and protocols. Just a few of examples of some of the guidance documents that we follow on a daily basis. Regional Implementation 1 for New England, RIM 2, Southwest Regional Implementation Manual, and then there's Region 10 for the Puget Sound, Pacific Northwest. There's many. I could have made several lists of these. Dredging material characterization and sediment cleanup assessments generally involve the use of a variety of physical and chemical, biological information to reach kind of a decision about risk and how to dispose or remediate contaminated sediments. So many sediment management programs require extremely low level detection limits. A lot of times this presents a challenge to the laboratory due to the potential analytical interferences related to complex matrices that we typically see in sediments and tissues as well as marine waters. So over the past 25 years, we've developed expertise and techniques necessary to perform complex trace analyses in all these matrices. Specialty techniques include unique sample preps, variations of extractions and cleanup procedures, as well as specialized instrumentation approaches to circumvent and address various matrix issues. Sample prep, it's all in the details. So in regards to sample prep, the importance and absolute necessity of thorough homogenization in any matrices you're dealing with is recognized by our lab as being an integral part of our standard operation procedures. So for instance, on biological tissues, we use a variety of grinders and blenders and ultra small blenders for homogenization process, and depending on the size and the type of tissue. We also have the capability to perform cryogenic grinding of tissue, which is usually performed when we're prepping for mercury or even organic constituents. And so we do a cryo grind with either liquid nitrogen or carbon dioxide pellets so that we minimize the amount of loss of sample due to heating from the blades and evaporation. Freeze drying of tissues, that's a routine procedure for metals prep. The whole reason to do that is to try and create a large representative sample from the homogenate. And so after freeze drying, so we homogenize them, we'll freeze dry, and then the subsample is further homogenized to make a fine meal in preparation so we can remove another aliquot to go to acid digestion for metals analysis. If you try drying it in an oven and then trying to homogenize it, you end up trying to homogenize shoe leather, usually what it ends up being. So freeze drying works very well. Dissection, we offer all types of dissection of various tissues, fish filleting, shucking, specific organ removal. We've homogenized 35-pound Chinooks, and we've worked with removing deer mice livers for trace metals, so a wide variety. Sediment sample generally mixed, is in a received container, but we'll also put that in a larger container to get better mixing, particularly of supernatant water that may have separated out, and the client wants that mixed into the sediments. Drying of subsamples for organic analysis is really done by the conventional drying agents. Anaerobic preparation. So we maintain capabilities and use on a routine basis manipulating of samples under anaerobic conditions. So we will put those samples in glove boxes that are being purged with argon or nitrogen. And it's typically incorporated in the preliminary treatment of sediments when conducting pore water extractions for contaminants such as butyl tins or other analytes that are sensitive to air. Another common application is when prepping sediments for sulfide determination, acid volatile sulfides, total sulfides, reactive sulfides. We're always worried about the loss of sulfides due to oxidation when you're doing preliminary handling of a sample. So ALS provides various extractions that are often used in conjunction with bulk sediment determination. Procedures generally fall under one of the following. Pore water extractions. Interest in pore water is to look at the interstitial waters of the sediments rather than doing and analyze those for contaminants rather than doing the total sediment and the pore water, because this kind of tells you what's bioavailable and what is actually coming out of the sediment into the interstitial waters. We traditionally use an EPA Region 10 Army Corps of Engineer protocol. And again, manipulation of these samples is performed in the glove box. These are sealed up with a anaerobic headspace, and there's double centrifuged and refrigerated are sent in centrifuges, and then we're able to put those back in the glove box and take off the pore waters. Elutriations, these are various types of extractions that related to dredging and dredge material management, usually follow the Corps of Engineers methods. So here we have effluent elutriates and modified elutes, which are tests that you use to determine what potentially could be leaching out of nearshore upland confined disposal facilities. Dredge elutriate is tests done with site water and site sediment to determine what could potentially be released at the dredge head. And then standard elute is what you might see if you go to open water disposal. When the dredges or the big dump barges to let all that fall into a confined disposal area. They want to know how much of the contaminant is being resuspended back into the water from that operation. Sequential and selective batch extractions, we support a wide range of those. Usually they're customized, but we do follow published ASTM methods, exist for some of these procedures. But again, they're mostly a technique that's mixed between client needs and published methods. Okay, so physical geotechnical tests, we support several of those. Kind of the most common requested ones are listed here. Many times particle size distribution tests are often customized to meet project requirements, but most of the time they follow ASTM methods or Puget Sound Estuary Protocol methods. Usually when there's modifications, it's change in a sieve size, or maybe somebody wants to use hydrometer over pipette. Specific gravity, pretty standard. Atterberg limit is a basic measure for the critical water content of fine grained soils. It's also they look at shrinkage limits, plastic limits, and liquid limits. And then total solids, total volatile solids. Pretty normal standard stuff. Conventionals. Here we offer a lot of conventional tests that are run on sediments. Most common ones would be total organic carbon. We do a couple different tests, a high temperature dry combustion, and then we also offer and various methods within between there. Also offer a Walkley black, which is your oxidation occurs through using a dichromate oxidation procedure. We do dissolved organic carbon, which is just a filtration of the sample prior to doing a TOC. We can offer carbon black. It's a Gustafson project or SOP method. Particle organic carbon, usually done by EPA method 440, where you do a filtration and look at particular organic carbon in fresh waters and coastal waters, marine waters. Total carbon, we can do that as well, and total inorganic carbon. Ammonia is pretty standard test. Sulfides, we talked a little bit about that. Typically, you'll end up running acid volatile sulfides and along with simultaneously extracted metals. So AVS-SEM, for you guys who are not familiar with that, it's a EPA draft method, and what you end up doing is a test for acid volatile sulfides, and then you also look at the metals that are in the extractive, typically cadmium, copper, nickel, lead, zinc. Sometimes we also include silver and mercury. And what you're doing is this method gives you a stoichiometric balance to evaluate, is there enough sulfides there to bind all of the metals that are in the sediment, making them non-bioavailable. And so what we end up looking at, looking at the metals and the sulfide levels, acid volatile sulfide levels. And of course, if there's more metals than there is AVS, then you're going to have bioavailable metals. And if there's more AVS than there is sulfides, they're likely going to be bound and then pretty much just turned into an insoluble sulfide salt. Okay, so into metals, ALS performs analysis of metals, metalloids, utilizing numerous procedures, various modifications of those procedures, but for the most part, metals just follow standard published metals as methods by EPA. So aqueous digestion is performed using conventional methods unless more complex digestions are required. So we're using EPA method 305 and 3010 for the most part. If samples have a high dissolved particulate content or high dissolved salt content, we're going to either have to dilute or do a chemical separation on these to get the salt out. And usually you could just do a simple dilution and not jeopardize detection limit requirements. But if the salt content is very high, we'll end up doing a chemical separation that usually falls under method 1640. On that, there's two techniques there. You can do a reductive precipitation or an online chelation extraction. We prefer the reductive precipitation, and basically you just take the liter of seawater sample and you precipitate out the metals of interest and then pour off the seawater and then bring back the precipitated metals back in an acid and analyze. Sediment digestions, conventional procedures using a nitric acid, hydrogen peroxide, maybe hydrochloric acid, usually following method 3050, fairly normal. Sometimes we need total dissolution using hydrofluoric acid, 3052. We do that. We see a lot of that in deep sea mining projects that we support. We're seeing a lot of that going on for investigative work for precious metals. Tissue digestions. So once we've gone through the freeze drying and homogenization is complete, samples ready for subsampling, digestion is usually performed with an in-house SOP, but consists of a nitric acid procedure in a closed Teflon vessel. We heat that in 105 C and cook everything down for 16 hours. That gets rid of all of the potential carbon interferences produced by carbon. And you can do that for both ICP and ICP-MS. We use the same prep. Clean room preparation ALS, we perform this in class 1000 clean rooms with class 100 laminar flow hoods. A lot of the prep that we do in there for the ultra low trace metals, particularly mercury, but also prepping of special sampling equipment for the field when they're doing clean hand sampling technique in the field. We've also started bringing some of the ultra low level sub-nanogram per liter level tests prep into the clean room as well. And we see more and more use for our clean room. Metals analysis, generally following EPA methods. I have it listed here, ICP, MS, and ICP optical emission. There's cold vapor atomic absorption, and then purge and trap cold vapor atomic fluorescence for mercuries. Mercury speciation, we can do total mercuries and methyl mercury. Mercury, depending on what level of, what method reporting level you need. We run 7,000 series, and then low level 1631. Methyl mercury follows EPA method 1630. And we use that in all, that method in all matrices. We also, for arsenic, will do speciation, a minimal speciation for inorganic arsenic, arsenic 3 and arsenic 5. And we do that in waters and tissues. That's following EPA 1632. So trace organics. And we offer a wide range of organic extractions and cleanup and instrument analyses for tissues and sediments and waters. Typical organic extractions are listed here where we do oxalates, manual and automated, liquid-liquid extraction, microwave extraction, solid phase, set funnels, sonication extraction. Cleanups of organic extracts, very important. It's always performed for sediments and tissues at ALS. Aqueous samples are considered for cleanup on a case-by-case basis, but cleanups are usually always needed in sediments and tissues due to biological material interference, naturally occurring lipids in fish or in any tissue, partially hydrolyzed biogenic materials, sulfur from sediments, and petroleum products get in the way of things. So the typical list of cleanup procedures: silica gel, gel permeation is the tried and true kind of the standard to go to for all of our SVOCs, PCBs, pesticides. So we'll typically go through that. Then first is a primary cleanup, and then secondary, tertiary cleanups as needed. We'll employ fluorosil for some. For PCBs and a few select inert pesticides, we'll do sulfuric acid cleanups. You've got carbon cleanups, alumina cleanup. Alumina is a very highly porous and granular form of aluminum oxide and will absorb a lot of compounds at various pHs. Silica gels are used to pull out polar compounds. And as I was talking about, permanganate and sulfate cleanup, or sulfuric acid cleanup for PCBs. Trace organic analysis. Do a lot of instrumentation analysis, of course, in the sediments arena. So SVOCs, PAHs, alkylated pHs, biomarkers related to oil spills, all done by GCMS SIM, and sometimes GCMS-MS. pHs in pore water by solid phase microextraction, usually by GCMS SIM. SIM, selective ion monitoring, for somebody that doesn't know. And GC, gas chromatography, MS, mass spectroscopy. Pesticides and PCB air cores, PCB congeners run by gas chromatography, electron capture detectors. We also offer pesticides by GCMS-MS and, of course, high-res GC, high-res MS by 1600 methods, and PCB congeners as well by high-res 1668, DACs and furans, and PFAS, alkyl substances, which is in the news daily. That's now getting into the sediments arena. Pharmaceutical and personal care products have become what I would call maybe an emergent contaminant for tissues. For sediments. We've been looking at them for the last 10 years plus, but considering the other contaminants, which we've been looking at for much longer, but pharmaceutical and personal care products have been of more interest in the sediments arena just to use as investigative work determining sewage tracement from POTWs and on-point source discharge, as well as laying blame on to maybe POTWs that aren't working properly. But yeah, it's certainly something we see more and more of on a daily basis. So that's kind of it. If you have any questions, like Malia said, you can, I think, type those in, or certainly if you want to send me an email, feel free to do so. Thanks again.
Thank you, Howard. We will open up the forum for questions now. We invite all our attendees to type your question in the bottom right-hand corner of your screen in the chat box. I will give everyone a few moments to type in their questions and I'll go over some brief notes. This webinar presentation is being recorded. All participants of this webinar will receive a follow-up email once the recording is available to view. We also post our webinars on our ALS Global website and our ALS YouTube channel in the webinar playlist. I encourage you to find a wide range of video resources and past Webinar Wednesday presentations available there. Also, please follow our showcase page on LinkedIn as we post announcements and registration links to future webinars and other valuable resources and updates. I'm going to give everyone just a few more moments to type in a question. Also, as Howard said, you can contact him by email or call him if you have a specific question. Howard, we do have a question. Guy asks, regarding marine sediment monitoring programs, what Canadian regulations guidelines do you provide services in support of?
I will need to check with our ALS Canadian laboratories. They do support that work. I tend to be more involved in the US work. I would have to confirm with them. I certainly can do that and get you the information. If you want to go ahead and email me, I can get you some details on what they will support in Canada.
Thank you, Howard. Again, we'd like to thank everyone for attending today. Remember to watch for the recording, which will be sent out to you via email. Thanks, everyone, and enjoy the rest of your day.